So today we'll be covering a new topic which is of a pure mathematics 1. So the topic that we'll be covering today is algebra. Okay, so this is your Cambridge International AS and A level. It is valid for both AS and A level, and we'll be starting a new topic which is our algebra of pure mathematics 1. Okay, so this is the topic of your pure mathematics. Okay, so we'll just go through some of the concepts that we have earlier studied, and also we'll also revise a few concepts which are new. Okay, so first of all, we'll just understand what surds are. Okay, so the topic of this algebra chapter which we are going to start is surds. Okay, so we'll understand what surds are. Okay, so what are surds? Surds are those numbers, or you can say surds are those things which you can't simplify. Okay, for example, you're having any number and you can't simplify it further, okay, by removing a square root or a cube root, then that number is known as a surd. Okay, for example, you cannot say that your number 2 or number 3 is a surd. Okay, no, they are not surds. When we can't simplify a number to remove a square root or a cube root, then that is a surd. Okay, for example, square root of 2 can't be simplified further, so it is a surd. Okay, it is a surd because it cannot be simplified further, so root 2 is your surd. Now if you take the example of root 4, okay, square root of 4, so square root of 4 is not a surd because it can be simplified to 2. We know that root of 4, we know that root of 4 root of 4 can be written as under root of 2 square, and when you simplify it, it will be 2. Okay, so 2 is a whole number, right? 2 is a whole number, or 2 is a natural number. Okay, so that is not a surd. For a number to be a surd, it should have at least a square root or a cube root. Okay, and when we cannot simplify it further into a natural number or a whole number, then that number is known as a surd. For example, root 2 is a surd, root 3 is a surd. Okay, now if you have a number like 2 plus root 3, okay, if you have a number like 2 plus root 3, then this is also a surd. Because see, this is not a whole number, this is not a natural number, and you cannot simplify it further. You cannot add root 3 in 2. You cannot add 2 plus root 3. Okay, so this is the simplest form of that number. So this is known as a surd. Okay, so surds are basically those numbers which have square roots or cube roots. Okay, and which cannot be simplified further. So there's one more property of surds. Surds may be added or subtracted just like other algebraic expressions. Okay, they can be added and subtracted just like we add or subtract other expressions, until and unless you keep the rational numbers and the square roots separate. Okay, you cannot add a rational number or a whole number or a natural number into a square root number or a cube root number or any other natural or any other square root or cube root number. Okay, so surds are added and subtracted just like how we do normal operations in algebra, unless and until we just have to keep in mind that we have to separate the rational numbers, like rational numbers will be added or subtracted with the rational numbers, and square roots or cube roots will be added or subtracted with square roots or cube roots. For example, we'll just take a situation, and we just take one question. Suppose you have this 2 root 3 plus 5 root 3. Both are surds. This is a surd, this is a surd. This whole expression is also a surd. Okay, and now you have to perform the addition operation on these two surds. So what you'll do, we'll just take root 3 common, and what will be left in the brackets? 2 plus 5. So what will be your answer? Your answer will be 7 root 3. Okay, so this is a surd. Now this is a surd. Now we have performed simple addition on these two types of surds. What we have done, we have separated the square root number, okay, and we have added the rational numbers, which is 2 and 5 over here, and we have just added the rational numbers separately, and then we have separated the square root number, and then we have written our answers. Okay, so 2 root 3 plus 5 root 3 is equals to 7 root 3. Okay, so this is how you add or subtract surds. You just keep the rational numbers separate, and you just keep the square roots or the cube roots separately. Okay, now we'll just go through a few examples so that it is more clear to you. So here we have to simplify the following, giving your answers in the simplest surd form. Okay, so this is your question. You have root of 32. Okay, now root of 32, you have to simplify this. You have to simplify, this is a surd because it is under root. So you have to simplify it, and we have to write our answers in the simplest surd form. So now we know that root of 32 can be written as under root of 16 into 2, because we know 32, we have written 32 as a product of 16 and 2. Okay, so under root of 32 can be written as under root of 16 into 2. Now we have separated these two terms. We have separated these two surds. Okay, we have written root 16 into root of 2. We can write it like that. Okay, now we know that root of 16 is 4. So we have written 4 into root 2. So this is 4 root 2. Now this is the simplest form of your surd. This is the simplest form of your surd. This thing cannot be simplified further. You cannot simplify it more. Okay, so this is your simplified surd form. Okay, now we'll take another example. For example, we have 4 root 7 plus 3 root 5 minus 3 into root 7 minus 2 root 5. So first of all, what we'll do here, we'll just open the brackets and then we'll multiply it. So when we'll open the brackets, what we'll get 4 root 7 plus 4 into 3 root 5 is 12 root 5. Here we have multiplied the rational number with the rational number, and we have kept the surd separately. Okay, and now we have multiplied 3 and root 7 minus 3 root 7, and here plus 6 root 5. Okay, now what we'll do, we'll collect all the like terms. We'll collect all the like terms. Okay, so when you'll collect all the like terms, what will be your answer? 4 root 7 minus 3 root 7. So what is 4 root 7 minus 3 root 7? It is 1 root 7. Okay, so this is root 7, and 12 root 5 plus 6 root 5 is 18 root 5. 18 root 5. Okay, so here also we have subtracted 4 minus 3, and we have taken root 7 as common, and in the brackets there will be 4 minus 3, hence root 7, and here also we have done the same addition like we had discussed earlier. Okay, so rational numbers, you just have to make sure that rational, whenever you are adding or subtracting surds, you just have to separate rational numbers and your square roots and cube roots. Okay, we'll take one last example. Suppose you have this question, 2 of under root x plus under root y minus 3 into under root x minus under root y. Okay, now if we'll just open the brackets and solve this question, what we'll get? We'll get 2 root x plus 2 root y minus 3 root x plus 3 root y. Collect all the like terms. Collect the like terms. So when we'll collect the like terms, so like terms are 2 root x and minus 3 root x. Okay, your one like term, and the other is plus 2 root y plus 3 root y. So when you'll just take the when you'll take the subtraction, so we'll take root x as common. Okay, we'll take x as common, so root x, and in the brackets what will be left in the brackets? 2 minus 3, and we'll take root y as common, so in the brackets there will be 2 plus 3. So what will be your answer? Your answer will be 2 minus 3 is minus 1 minus root x plus root y into 5. Okay, so now we'll just rearrange this into 5 root y minus root x. Okay, we have written it in this form. So we don't miss out the minus sign, because when we are writing an expression in which we have the first term with the negative sign, we often tend to miss it. Okay, so that's why we have rearranged it in this form. Okay, So this was just how what your surds actually are and how we add and subtract surds, how we manipulate surds and what are surds. We have learned everything in this lecture. So we'll just continue our lecture. We'll just continue our topic in our next lecture.